So in this first video, we're going to talk about the Unit 4 straight line motion with other miscellaneous things. So L'Hopital's rule, straight line motion, and related rates were the three things we did in Unit 4. I already did all the questions in another video for L'Hopital's rule, so there are no new L'Hopital's rule questions that you'll see in this video, but back in the second video, I did some on L'Hopital's rule. Straight line motion is the main topic we're going to talk about right now, and then related rates as well we will talk about in some of these questions. So let's go ahead and get started. We'll look at some of these examples. There aren't any on the first page or the second page. The first one we'll look at is number 15. So I'll go through the problem, and then if you guys have questions, please feel free to stop me, and then we'll talk about it together. So for number 15, it says the top of a 15-foot ladder rests against a vertical wall. I'm just going to draw a picture of what this might look like. I'm going to label these sides A, B, and C. So the ladder itself is 15 feet. So if I'm going to label all my variables, I have A, B, and C. I want to know how quickly A is changing, that's dA dt. I might know how quickly B is changing, that's dB dt. And I might know how quickly C is changing, that's dC dt. So they're telling me that the ladder itself is 15 feet, so I know that C is 15. It says it rests against a vertical wall with the bottom of the ladder on level ground. As shown above, the ladder is sliding down the wall at a constant rate of 2 feet per second. So the ladder is sliding down the wall. So in my little triangle I've drawn, I've labeled that side B. So that means that side B is changing at a rate of 2 feet per second. And since it's sliding down the wall, that means that side is getting shorter. So I'm going to label dB dt as -2. Since it's getting shorter, it's negative. It says, at what rate in radians per second is the acute angle between the bottom of the ladder and the ground? That's this angle right here. They want to know at what rate that angle is changing at the instant that the bottom of the ladder is 9 feet from the base of the wall. So the distance between the bottom of the ladder and the wall in my little triangle is represented by side A. So they want to know how quickly this angle is changing when A is 9. So that's all the information that's given to us. Now, notice that this is not actually a Pythagorean theorem problem in terms of the relationship. They want to know at what rate the angle is changing. So angles in triangles need the trig ratios, either sine, cosine, or tangent. Well, since we know the rate that B is changing, they told us that dB dt was -2. We also know dC dt. C is a ladder, and a ladder does not change its length. That means that C is not changing. So dC dt is equal to 0. We don't know dA dt, so that one's still blank. B we can figure out using the Pythagorean theorem. So if we do 15 squared, which is 225, minus 9 squared, which is 81. I know this is a non-calculator question, but I'm going to go ahead real quick and get out a calculator, because I can. I don't think there's one on your test that requires big number math, though. All right, you get 144 when you subtract those. I know you could do it by hand, but I won't bore you in a video of doing that by hand. So 225 minus 81 is 144. The square root of that would be 12. So side B must be length 12. So last but not least, we need an equation that's going to relate together this angle with at least 2 of these sides, depending on if we want sine, cosine, or tangent. Now, notice that we have some information missing from dA dt. Since we don't know anything about dA dt, I'm going to try to avoid that side as much as possible since I'm missing some information about it. So I don't want any trig ratio that needs this side of the triangle. So in relationship to this angle, that's the adjacent side. So the only trig ratio that does not deal with the adjacent side is sine. So I'm going to go ahead and set up a sine ratio. So sine of theta is equal to B over C. And since we're doing a related rates problem, we need to take the derivative of that. So the derivative of sine of theta, be careful with this. theta is changing. It's not a constant value. So when we take the derivative of sine of theta, we have to use the chain rule. The derivative of the outside is cosine of theta. But then we have to multiply it times the derivative of the inside. So the derivative of theta itself is theta prime, since it's changing. And that's actually what we're looking for. We're trying to solve for that value. We want to know how quickly that angle is changing at the rate when the side is when the ladder is 9 feet from the bottom of the wall. All right, so that's the derivative of the left-hand side. On the right-hand side, we have b over c. So if we're going to take that derivative, we need the quotient rule. So quotient rule says derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. That's quotient rule. So b prime times c minus b times c prime all over c squared. We're kind of running out of room here. So I'll try to bring it over here just a little bit. All right, we need to know a couple things in order to be able to plug them into this equation. I need to know what b prime is. So we know that b prime is -2. I know that c is 15. I know that b is 12. And I know that c prime is 0. So I'm going to plug all of those things in on the right-hand side. The other thing I need to know, and the last thing I need to know, is what cosine of theta is. Now, keep in mind that cosine of theta, if you look at this triangle over here, cosine of theta is just the adjacent side over the hypotenuse. So the adjacent side is a, and the hypotenuse is c. So cosine of theta is the ratio of a divided by c. So if I look at those values, a is equal to 9, c is equal to 15. So cosine is just 9 over 15 of that angle. So let's plug everything into the equation. All right, we know that cosine of theta was 9 over 15. I'm solving for that theta prime, so I'm going to leave theta prime there. For b prime, I know that b prime is -2. I know that c is 15. For that next term, I have b times c prime. Well, b is 12 and c prime is 0, so 12 times 0 is just 0, so I'm not going to even include that next part. And then all over c squared. So c squared would be 15 squared. So if I go ahead and continue to simplify this, I get -2 times 15 over 15 squared. Well, one of those factors of 15 is going to cancel, so that's just -2 over 15 equals theta prime times 9 over 15. And then if I multiply by the reciprocal on both sides, 15 over 9 times 15 over 9, I get that theta prime is equal to the 15s divide out to make 1, and I'm left with -2/9. Answer choice A. The next one I want to look at is number 27. Flip with me to number 27. Number 27 is also a related rates problem. It says functions w, x, and y are differentiable with respect to time and are related by the equation w equals x squared y. It says if x is decreasing at a constant rate of 1 unit per minute. So I'm just going to go ahead and write down all of our variables. So I'll take the space up here. We have w, x, and y. And then w prime, x prime, and y prime. It says x is decreasing at a constant rate of 1 unit per minute. So x prime, I should say, is -1 unit per minute. It says y is increasing at a rate of 4 units per minute. So y is +4 units per minute. And then it says at what rate is w changing with respect to time when x equals 6 and y equals 20. So x is 6, y is 20, x prime is -1, y prime is 4. They want to know what w prime is. That's our unknown. So the only thing we don't have information for yet is w, but we can figure it out from this equation. They gave us this equation w equals x squared y. So if I want to know what w is, plug in x equals 6 and y equals 20. So if I plug in x equals 6, that's 6 squared, which is 36. And then 36 times 20 is 720. So w is 720. I have no idea if I'll need that or not. I actually am thinking forward right now, and I just realized we don't need it. But in case you weren't quite sure, that's how you would figure it out if you did need it. Now, the reason I know this is a related rates problem, by the way, is because it says W, X, and Y are all differentiable with respect to time. And then the unknown is this. They want to know what rate W is changing at. So I'm looking for a rate W is changing at. That's W prime. And since everything is relating with respect to time, that kind of should bring up feelings of related rates. All right, W equals X squared Y. We need to take the derivative of that function. So we have W equals X squared Y. All right, this derivative is a little gnarly. The derivative of W is W prime. The derivative of X squared Y, since neither of those are the important variable is time, we have to use the product rule. Inside of the product rule, however, we're going to need the chain rule for the derivative of X squared. So I'm going to go ahead and set that up. I'll just write it out. If you have questions about it later, you can ask me though. So product rule. Product rule says derivative of the first. So I want to know the derivative of 2x. I'm sorry, x squared. The derivative of x squared is 2x. But since this is a related rates problem and x is not the important variable, then not only is the derivative 2x, but then times x prime. That's the derivative of the first piece. The derivative of x squared is 2x times x prime. So product rule says derivative of the first, got that, times the second, so times y. Plus the first, which is x squared, times the derivative of the second, so times y prime. And now we have the derivative of w using the product rule and the chain rule. All right, let's go forward. We're looking for w prime. Let's plug in everything we know about x, x prime, y, and y prime. So 2 times x would be 2 times 6, times x prime would be -1, times y would be 20, plus x squared would be 6 squared, times y prime, which is 4. If we go forward and multiply all that out, 2 times 6 is 12. 12 times 20 is 240. And then 240 times -1 is -240. 6 squared is 36. 36 times 4, what is it? 144. So that's plus 144. And last but not least, -240 plus 144 is -240 plus 144 is -96. Answer choice C. All right, number 30 says a particle moves along the x-axis so that at time t, in between 0 and 1, its position is given by this function. It says find the value of t that the particle is at rest. So a particle is at rest whenever the velocity is equal to 0. So I need to know what the velocity is first. So if I want to find the velocity function, I'm going to take the derivative. The derivative of sine of 2 pi t requires the chain rule. So derivative of the inside, the derivative of 2 pi t is 2 pi. And the derivative of the outside is cosine. The derivative of sine is cosine. So that's cosine of 2 pi t. So that's the derivative of the first term. And then the derivative of 2 pi t, that second term, is just 2 pi, so plus 2 pi. So that's the velocity, and they want to know when the particle is at rest. So the particle will be at rest wherever velocity is 0. In order to solve this, we need to get t all by itself. So the first thing I'm going to do is subtract 2 pi over to the right-hand side, and then I'm going to divide by 2 pi. So let me zoom into this a little bit so you guys can see it. So if I subtract 2 pi over and divide by 2 pi, I get that cosine of 2 pi t is equal to -2 pi over 2 pi, which is just 1. And then, -1, excuse me. The next thing we need to know is I need to answer the question, what would I be plugging into this cosine function to make it equal -1? So I want to think where on the unit circle cosine is equal to -1. And that would be x is equal to -1 over at pi. So cosine is equal to -1 at pi. That means this entire thing inside of that cosine function is equal to pi. So 2 pi t is equal to pi. Because if this is equal to pi, then when I plugged it into the cosine function, it made cosine equal -1. And last but not least, to solve that, we would divide by 2 pi on both sides. So I get that t is equal to pi over 2 pi, which is 1 over 2. Answer choice D. All right, for number 4 in the calculator section, we have a particle moves along the x-axis so that its position at time t greater than 0 is given by x of t, and dx dt equals this function. It says the acceleration of the particle is 0 when t equals blank. So first of all, position is x of t. The derivative of x, what do you get when you take the derivative of position? Velocity. So essentially they're telling us that this is the velocity function. So if this is velocity and they want to know about acceleration, how do I get from velocity to acceleration? Find the derivative. So in my calculator, I'm going to plug this function in, and then I'm going to find the derivative of it and evaluate at 0. They want to know the acceleration of the particle. Oh, sorry, the other way around. I misspoke. They don't want you to evaluate at 0. They want to know what time value made the acceleration equal 0. Let me write that down. We're solving for t such that a of t equals 0. So I want to know the answer to that question. What t value makes the acceleration equal 0? So in order to do that, we need to take the derivative of this function in order to be able to find out what the equation is that we need to set equal to 0. So the derivative of this, which is the second derivative, d squared x dt squared, the acceleration, would be -40t cubed plus 18t plus 8. That's the acceleration function. And I want to know where that function is equal to 0 because I'm solving for the time value that makes the acceleration equal 0. So here's how we're going to do it. We're going to get our calculators. We're going to plug our acceleration function into our calculator, -40x cubed plus 18x plus 8. And then again, there's multiple ways. You can either tell your calculator to find the 0 for you. For me personally, though, I like to find the intersection. So I'm going to figure out where this function intersects the line y equals 0. So I'm going to go to the graph. Let me make sure my window looks good. I'm going to change my window. If you're curious, by the way, about what x values you need, look at the answer choices. The answer choices go from 0 all the way up to about 10. So I'm going to make my x values go from 0 up to about 10. I have mine at -4 to +4, but I probably don't even need that much. I just want to know where it intersects the x-axis. I want to know where acceleration is 0. So I can see it right here. That's the time where it's equal to 0. This is the acceleration function being equal to 0. If I'm looking at the answer choices, it looks like it's a little less than 1. And the only answer choice that's a little less than 1 is 0.831. So if I trace 0.831, that is the exact 0. So that's the correct answer. You could use the calculator to figure out the intersection for you, but since it's multiple choice, you can just use trace to do it as well. Number 10 says a particle moves along a line so that its velocity is given by this function. It says for what values of t is the speed of the particle increasing? So let me graph this first. So if I graph this, it's going to be negative x cubed plus 2x squared plus 2 to the power of -x. Now, in terms of values, like x values I need to be looking at, we're going all the way from x equals about 0, and then the highest x value I see is at around 2. So I'm going to go from 0 to 3. I'm going to look at 0 to 3 on my window. We'll see if the y min and y max is good enough at -4 and +4 when we graph it. So let's see what it throws out at us. All right, so it looks like that. It looks like I have too much on the top. I don't need that much all the way up to -4. I'm sorry, all the way up to +4, but I don't see enough of it on the bottom. So I'm going to redo my window. I want to see a little bit more at the bottom, so I'm going to change it to -6, and I don't need as much at the top. So I'm going to change my y maximum to 2. So I want to see from -6 to 2. And then I'm going to regraph it, see if I can get a little bit of a better picture of my function now. All right, I still didn't get all the way to the bottom, but I think that's okay. We got most of it, so it should be good. Now, here's the thing. It says, oh, actually, is that good enough? 1, 2, yeah, that should be okay. It says, for what values of t is the speed of the particle increasing? So remember that speed is increasing wherever velocity and acceleration are the same signs. So here's what that looks like graphically. Right here, velocity is positive. All the way up till about 2, velocity is positive. And then after 2, velocity is negative. Acceleration is the derivative of velocity. So let's look at the slopes. If you look right here, let me zoom in so you guys can see it a little better. If you look right here, it looks like this function is increasing up until about this point. So in this area right here, the function is increasing, which means it has a positive slope. So if velocity is positive, since it's above the x-axis, and acceleration is positive, since it's increasing, that means that speed is increasing. So from about 0 to whatever point this is, speed is increasing. Then the velocity function starts going down. So since now velocity is decreasing, but remember, since the, since the velocity is positive but acceleration is negative, then speed is decreasing right here. And then over here, velocity is negative now since it's below the x-axis, and it's decreasing, which means acceleration is negative. So since they're the same sign again, then we would say that the speed is increasing again here. It's just increasing in the negative direction. So it's increasing in between these 2 points, and it's increasing after that point. So let's look at our answer choices and see which ones we think most closely resemble that. So from, I see 0 to 0.177. I don't think this point right here is 0.177. I think it's closer to maybe like 1.256. Let's check. I'm going to push trace and then 1.256. Yep, do you guys see my little blinking star up here at the top? So that's the maximum at 1.256. Now, there's 2 intervals where speed is increasing. It's increasing from 0 to 1.256. So it can't just be that interval. There has to be a second one. It's also, oh, and I guess it's 0.177. It's not exactly 0. It's also increasing from, I'm guessing, 2.057 to infinity. So let's make sure that this point right here where it crosses the x-axis is 2.057. So trace 2.057. And yes, that is in fact the blinking star to show me that that's the other interval. So E is the correct answer, from 0.177 to 1.256, since velocity is positive and acceleration is positive, since it's an increasing function, and also from 2.057 to infinity, since velocity is negative and it's decreasing, which means acceleration is also negative.